Trigonometric functions. Exact the value of special angles. Those angles are 30 degree, 45, 60 degree. There are several ways to remember those special values. One of them is using triangles. We had two special triangles, 1 and 1. If I have isosceles triangle, right, isosceles triangle, then the 1 square plus 1 square is 2, so this one is square root of 2. And those angles 90 degree, so those ones are 45 degree, 45 degree. Or you can use the triangle, and then you have sine opposite over hypotenuse, and tangents adjacent over hypotenuse, and so on. So we have this for 45 degree, and then we can have this for 60 degree, 30 degree, and those ones is 1, 2, and root 3. If you know how to use it, you can use those ones, or you can use the unit circle, or I use the chart, and I'm gonna show you the way I remember them. That means by chart. So the chart is very easy to make the chart. It starts like this. I have the angles, so it goes from the smallest 30 degree, 45 degree, and then 60 degree. And then I have this sine theta, cos theta, and tangent theta. Okay, so now I need in radians. 30 degree is nothing else but pi over 6. Pi over 6. How do I remember this? Basically 3 changes to 6. 45 is pi over 4, and 6 changed to 3, so it's pi over 3 in radians. And now please pay attention, how do we construct this? So sine, I will write everything is over 2, everything is over 2, everything is over 2. Okay, and now on top I can write 1, 2, and 3. And I take square root of everything. Square root of 1 is 1, so I'm gonna leave it. Square root of 2 and square root of 3. And that's it. Those are my values for sine. So sine 30 degree is 1/2. Sine 45 degree is root 2 over 2. Sine 60 degree is root 3 over 2. Or sine pi over 6 is 1/2. Sine pi over 4 is root 2 over 2. And sine pi over 3 is root 3 over 2. And now cosine are exactly the same values written from the backwards. So cosine is root 3 over 2, root 2 over 2, and this one is 1/2. So now if you have cosine 45 degree, is nothing else but root 2 over 2. Or cosine pi over 3 is 1/2. Okay, and tangent, we know that tangent is sine over cosine, so we can just divide those values. Tangent is sine over cosine, sine over cosine, so this one is 1/2 over root 3 over 2. To divide the fraction means multiply by its reciprocal, so this one is 1/2 times, flip this over, so we have 2 over root 3. 2 and 2 cancel out, so the value is 1 over root 3. So the tangent, the first value is 1 over root 3. Root 2 over 2 divided root 2 over 2, those are exactly the same terms. When I divide them is 1. And those two, when I divide, flip the second fraction, I will get root 3. So that's how I remember the special angles values, and everyone should know them, either using triangles or unit circle or this chart. So tangent, the chart goes tangent pi over 6 is nothing else but 1 over root 3. Tangent pi over 4 is 1. Sine pi over 3 is root 3 over 2. So now we have example. Find the exact value of each expression, and we have A. We have sine 30 degree times cosine 45 degree. It's very good for exercises to draw your little chart, then you will always remember. So we're gonna use the value from the chart. We need sine 30 degree is 1/2 times cos 45. Cos 45 is root 2 over 2. Then how do we multiply fractions? Numerator times numerator, denominator times denominator. So 1 times root 2 is root 2. 2 times 2 is 4. So that's the exact value. Now we have B. We have tangent pi over 4 minus cos pi over 6. So when we look into the chart, tangent pi over 4 is 1. Cos pi over 6 is root 3 over cos pi over 6 is root 3 over 2. So now we can rewrite, we can leave it like this, or we can find the common denominator, because 1 is like 1 over 1. So common denominator of 1 and 2 is 2. Multiply times 2, multiply times 2. So we have 2 minus root of 3 over 2. Example C. We have tangent squared pi over 3 plus sine squared pi over 4. Okay, so we need to find these values. So tangent, and then we need to square the tangent. So I'm looking into my chart. Looking into my chart, tangent pi over 3. Tangent pi over 3 is root of 3. So we have root of 3, and now I have square, so it's square root. Plus sine pi over 4. Sine pi over 4 is right here, so it's root 2 over 2 and square root, because I have square here. Okay, so root 3 square root is root 3 times root 3, which is root of 9, which is 3. Plus, and this would be root 2 over 2 times root 2 over 2. So I have root 2 over 2 square root is nothing else but root 2 over 2 times root 2 over 2. So this is root 2 times root 2 is root 4, which is 2. 2 times 2 is 4. And this can be reduced to divide by 2 to 1/2. So I have 3 plus 1/2. which can be written that this one is 3.5, or find common denominator. This is like over 1, so common denominator is 2 times 2. So this we will have 6 over 2 plus 1 over 2. And how do we add fractions? We add numerator, which is 6 plus 1 is 7, and copy the denominator, which is 2. Okay, let's do one more example. Let's do one more example, CD. The cosecant square pi over 6 minus 1. When I look into my little chart, I don't have cosecant, but I know that cosecant is nothing else but 1 over sine. So this one is 1 over sine squared pi over 6 minus 1. So we can write that this is 1 over sine pi over 6 and square it, and then we have minus 1. So pi over 6 is 1/2. So this value is 1/2. So this is equal to 1 over 1/2, square it, and then I have minus 1. 1/2 square root is 1/2 times 1/2, which is nothing else but 1/4. Have 1 over 1/4 minus 1. To divide by a fraction means multiply by its reciprocal. Flip this over, so we have 1 times 4 over 1 minus 1. So 1 times 4 over 1 is 4, so I have 4 minus 1, and the value is 3. Applications, word problems. Example 2. A surveyor can measure the width of a river by setting up points as on the diagram. Find the width of the river rounded to the nearest meter. So on the diagram, we want to measure the width of the river, and the surveyor was able to point the point A and B 100 meters away, and he measured the angle to the point C, which is 35 degrees. So we have the triangle, and we need to find this side X. Let's label it X. So regarding this angle, this side is opposite and this side is adjacent to that angle. What trigonometric function we can use that uses opposite and adjacent side? This trigonometric function is tangent. So tangent of my angle 35 degrees is opposite, which is X, over adjacent, which is 100. Now we can solve it. We can multiply times tangent 35 degrees is X over 100. We multiply times 100 times 100. Then this 100 cancel out. So my X is equal to 100 times tangent 35 degrees. Just make sure when you punch this on calculator that your calculator is in degree mode. Tangent 35 degrees. And the answer is that X is approximately 70.02. 70.02. So that's the width of the river, is approximately 70 meters. So X, we can write backwards 70 meters because this length is meter. So the width of the river is approximately 70 meters. Before we get to the next example, we would like to specify angle of elevation and angle of depression. So if I have my eye right here, that's my side, going straight from my eye, going up. This is nothing else. I can see some sun or anything else. So this is under right angle right here. So this angle is called angle of elevation. Angle of elevation. Angle of elevation is angle going upwards from the horizontal line. This is the horizon. This is the horizon that we see. And the same story can be angle of depression. If I am standing on some mountain, let's say that it's right here, standing on the mountain, and I look straight to the horizon, then I can see, looking down to some tree, that's gonna be, there's gonna be nothing else but the angle of depression. Angle of depression. Looking down from the horizontal line. This is the horizontal line, looking down. And this is called nothing else but the line of sight. Line of sight. So once we know what is angle of elevation, that's the angle between horizontal line looking upwards and angle of depression between horizontal line looking downwards. That's the angle of depression. Once we know those two angles, we can solve the next problem. A man is walking towards a building 70 meters high. If the angle of elevation to the top of the building is 20 degrees and the man is 1.7 meter tall, how far is the man from the building? So we have a tall building. Right? That's my building. And we have a man walking towards that building. And we know that the man is 1.7 meter tall. So the angle of elevation is from his side up to the top of the building, right? Up to the top of the building. Okay, so this angle is 20 degrees. We also know that the whole building is 70 meters, and we know that the guy is 1.7 meters tall. So, looking at our triangle, looking at our right triangle, that's my red triangle, we would like to know how far is the man from the building. How far is the man from the building? So that's this, that's gonna be my x. And we also know this side. If the whole building is 70 meters and this guy is 1.7 meters, a little bit not precise drawing, so we can calculate that this side is 70 minus 1.7, which is 68.3. 68.3 is this side. .3 is this side. So now what trigonometric ratio we can use that would use those two sides? Regarding this angle, this is adjacent to that angle, and regarding this angle, this side is opposite to the angle. Here's my right angle. So opposite and adjacent, it's gonna be tangent. So we have tangent 20 degree is equal to opposite, which is 68.3, divided by my x. So now we can multiply times x both sides, times x times x. X and x reduces, so what I'm getting is x times tangent 20 degree is equal to 68.3 all over 1, so nothing, over 1 we can say. So now we can divide by tangent 20, divide by tangent 20, divide by tangent 20 degree. So tangent 20 cancel out. So my x is equal to 68.3 divided by tangent 20 degree. So we can use calculator to get this value, 68.3 divided by tangent 20. Make sure you are in degree mode. So my x is approximately 187.65. So how far is the man from the building? Is 1.67 meters. So the man is approximately 187.65 meters away from the building. Example 4. A 20-foot extension ladder leaning against a building makes a 50-degree angle with the ground. How far up the building does the ladder touch? So the situation we have again the building. And then we have a ladder, and we know that the ladder is 20 feet long, so we can make the right triangle right here, identify the right triangle, and we know that that ladder makes angle of 50 degree with the ground. So here is my ground. So 50 degree is right here. So the question is, how far up the building? So that's how far, that's my x. So we can identify the red triangle, right red triangle, and we need to find the x value. So regarding this angle, this is hypotenuse because this is the side opposite to right angle, and regarding this angle, my x is nothing else but opposite. Opposite and hypotenuse, what trigonometric ratio is that? Sine theta, or 50 degree, is opposite, which is my x, over hypotenuse, which is 20. So now we can multiply sine 50 degree is x over 20. I will multiply times 20 times 20. This 20 cancel out. So we have that x is equal to, and we can punch everything on calculator, 20 times sine 50 degree. Make sure that you are in degree mode. So this is 15.32. 15.32 and feet, because the letter is in feet. So that's how far up the building, 15.32 feet up the building, the ladder touches the building. One more example, example 5. A radio transmission tower is 250 feet high. How long should a guy wire be if it is to be attached to the tower 15 feet from the ground and is to make an angle of 71 degrees with the ground? Draw a diagram. We have the transmission tower. That's my transmission tower. That's the ground. And we attach a wire guy somewhere right here. So we know that the whole transmission tower is 250. But we know that the wire guy is to be attached 15 feet from the top. So we know that this side is 15 feet. And makes the angle with the ground 71 degrees. So we can identify our right triangle right here, and they ask how long should a wire guy be. So this time we are looking for this value x, how long that wire guy should be. And we can calculate this value. We can calculate this value. It's nothing else but the whole tower, 250, and we subtract 15. So 250 minus 15 is 235. So this side is 235. So regarding the angle, this side is opposite right angle, so it's hypotenuse. This side regarding my angle is nothing else but opposite. Opposite and hypotenuse, what trigonometric ratio we can use? Is sine. So we have sine 71 degree is opposite. Opposite is my 235 side over hypotenuse. So now we can multiply times x. And x cancel out. So now we can divide both sides times x. So I have x times sine 71 degree is 235. Now we can divide both sides by sine 71, not by x, by sine 71, because we are solving for x. So this cancel out. So my x is equal to 35 divided by sine 71. And we can punch this on calculator. Make sure you are in degree mode. So the approximate value is 248.54 feet. So the wire, how How long should the wire guy be? So the wire the guy wire. The wire should be 248.54 feet long.